Hello everyone, welcome to our YouTube channel Electronics Maddie. In this video, we are going to talk about Supermesh, Supernode, the theory behind them, and few of the solved examples. So let's get started. So what is Supermesh? Supermesh is one of the most important concepts with respect to KVL. So let us consider the circuit. There are two loops. Current flowing through loop 1 is I1 and current flowing through loop 2 is I2. Whenever there is a current source connected between two loops, then the circuit is said to have a supermesh. So that is what it states. When a current source is connected between two meshes, then it is called a supermesh. So this is as simple as it looks like. So be very careful in identifying circuits whenever there is a current source in between two loops. You have to have a different approach with respect to it. I'll be showing few of the examples with respect to that. Once you are clearly aware of one or two examples, you will be able to identify them easily. But be very careful with respect to applying supermesh with respect to problems that are there. So what is supernode? So supermesh, as we spoke, it is with respect to KVL. Supernode is with respect to KCL, Kirchhoff's current law. So let us consider this circuit. Let us say this is V1 and this is V2, as there are two nodes over here. Whenever there is a voltage source connected between two nodes, then the corresponding circuit is said to have a supernode in it. So when a voltage source is connected between two nodes, then it is called a supernode. So whenever a supernode is connected, the approach will slightly be different with respect to our analysis part. Again, there will be a worked example shown to you to clearly understand what supernode is all about. So be very careful with respect to identifying a voltage source connected between two nodes. So once this is done, let's get into our first. All right, let's look into our first example. They have given us a network and they've asked us to find the current flowing through 10 ohm resistor. So if you carefully observe the circuit, it basically contains three loops, isn't it? So this is the first loop. This is the current flowing and it is given as I1. They've only given the directions as well. So if you carefully observe, there is a current source connected between loop 2 and loop 3. So that means there is one normal loop and then there is a super mesh. So be very careful with respect to this. So let's get started with having our circuit simplified. So first step is to redraw the network indicating sign. This is one of the most important steps. This step is very important because when you're solving these type of problems, there are chances that you might go wrong with respect to sign convention. So be very careful with respect to writing the signs properly. Our convention is very standard. We have used this throughout our videos. So current entering is taken as positive. Whenever a current is entering through a resistor, we'll be writing it as positive. Whenever it is leaving, we'll be taking it as negative sign. So this should be followed throughout. If you are using a different approach, that's still fine. You can have a different convention as well, but we are using this convention. So we have also solved few of the problems on KVL and KCL. The link of that is provided in the description. Please do watch if you want to solve more problems on it. So once this is done, the next step is to apply KVL to mesh 1. So how do we apply KVL with respect to mesh 1? So the current is starting from this point. So we will be assuming from this point. So it's from minus to plus. So whenever current is living at plus terminal with respect to voltage, we'll be writing it as plus. So the voltage here is 2 volt. Now minus 1 into I1. The why it is minus? Because current is entering positive and leaving at minus, so we'll be writing minus. The value of resistance is 1 and the current flowing through it is I1, so we'll be writing 1 into I1. So next is, again current is entering and leaving at minus 10 ohm, so we'll be writing minus 10 into I1 minus I2, because the current with respect to this loop we are considering. So always you'll have to write it as I1 minus I2. If you are doing it with respect to this loop, we'll write it as I2 minus I1. So this is one of the most important observations. So we'll be equating it to 0 according to KVL, because algebraic sum of voltages in any loop is equal to 0. So that is what is applied over here. So we'll further simplify this. We'll be getting 11I1 minus 10I2, that is equal to 2. So we'll be writing this as equation 1. So next step, so we have already identified this as our super mesh, isn't it? So how do we approach super mesh? It's very simple. If you see I3 and I2 directions, they've already given. So I3 is the direction in which current is also flowing over here, 4 amps. So we'll be writing I3 minus I2, that is equal to 4 ohms. The reason why we are writing I3, because the current I3 is also flowing in the same direction as 4 amps that is flowing. So we'll be writing I3 minus I2 is equal to 4 ohms. ohms, that is equal to 4 amps. So this is labeled as equation 2. Our next step is to apply KVL to the outer path of the super mesh. Usually what we used to do when there is a resistor here instead of a current source, we used to apply KVL to another loop over here. So three loops. But since it is a super mesh, we'll be applying KVL to the outermost path. That's it. So it's as simple as it looks like. So let's get started with applying KVL on this particular portion. So over here, as you see, the current is living at negative. So you'll be writing it as minus 10. As I told you earlier, since it's with respect to I2, we'll be writing it as I2 minus I1. So now minus 5 I1, I2 is the next value because the current is living at minus 5 ohms. So we'll be writing minus, and current that is flowing through 5 ohms is I2. So we'll be writing minus 5 I2. Next is, if you observe, this is the outermost loop, isn't it? We'll be continuing through this portion. So again, you have minus 15 into I3 because the current is living at minus terminal, and minus 15 is written. The current flowing through 15 ohm resistor is I3, and this is equated to 0 because algebraic sum of EMFs in a closed loop is equal to 0. So we'll be further simplifying this equation. You will be getting this particular equation. Further, we'll be labeling this as equation 3. Now solving equation 1, 2 and 3, there can be different approaches that can be used. You can use matrix method in order to solve them, but it's not shown, the calculations is not shown. You can directly get these values. You can also do it using a calculator as well. So you will be getting I1 is equal to minus 2.35 amps, I2 as minus 2.78 amps, and I3 as 1.22 amps. So you have found out all the currents. Now you have to find the current flowing through 10 ohm resistor. So how do we do it? There is current flowing, I1 is flowing in this direction and I2 is flowing in this direction. So I1 and I2 are in opposite direction with respect to each other with respect to 10 ohms. So current flowing through 10 ohm resistor is the question that is asked. That is nothing but I1 minus I2. So the reason why we are taking I1 minus I2 is that I1 value is very higher as compared to I2. If you see the magnitude as in negative direction, the value which is less will be higher than the value that is higher. So be very careful with that as well. So I1 minus I2 is the value that we are going to get, that is 0.43 amps. So the current flowing through 10 ohm resistor is 0.43 amps. So this is how we have to approach a problem which has super mesh in it. So hope this problem is cleared. We'll be solving another problem with respect to super node. So this is our example 2. They've asked us to find out the node voltages V1, V2 and V3. So how do we approach? It's as simple. The usual approach that we follow. First step is to redraw the network indicating current directions over here. This is very important. So I've labeled, there are three nodes. So with respect to all these nodes, other than the current direction that they have conventionally given in the problem, we are not supposed to change them. Other than that, with respect to this node, all the currents, the arrow marks that are shown are living currents. I have assumed it as living currents. So it should be uniform throughout the problem. You are not supposed to take one living and one entering, one living and one entering. Not, that is not supposed to be followed. So if you're taking it as living, you have to take it as living throughout the problem so that you don't go wrong while solving this problem. So I've taken currents living with respect to all of these nodes. If you see carefully, again this is our convention. We are following the same convention throughout. Current entering is positive and current living is negative. So first step is to apply KCL at node 1. So we know from Ohm's law I is equal to V by R, isn't it? So current living is taken as negative and current entering is taken as positive. That means current entering with respect to node 1 is 10 amps. So I'll be taking as plus 10, and current living with respect to first node is both these currents. So I'll be writing it as V1, that is equal, that is I can write it as minus V1 by 3, but I've taken it to the RHS side. I've skipped one step so that it like to reduce the number of steps that is involved. That's it. So it's very simple. V1 by 3 plus V1 minus V2. This is the voltage difference between these 2 points with respect to this current. So V1 minus V2 whole divided by 2. 2 is the value of resistance that is there. So why 10 is written directly? Because this is a current source and I is directly written here. However, with respect to I in these two cases, we have written with respect to Ohm's law, that is V by R. So this can be further simplified by taking common factors, and we'll be getting this as equation 1. So we'll be labeling that as equation 1. So step 2, if you carefully observe, this is a super node over here between voltage nodes V2 and V3. So we'll be identifying super node and we'll be writing an equation for super nodes. So applying KCL at the super node V2 and V3, you will be getting V2 minus V3 equal to 20 volt. You can take it in this way, you can also take it in the opposite way. However, since the terminals with respect to conventions that we are followed, plus is here and minus is here with respect to the given question, we will be assuming V2 greater than V3 because the terminal voltage plus is directly appearing at point V2. So we have written this and considered this as equation 2. So again, step 4 is to apply KCL to the super node. That is nothing but we will be applying KCL at these 2 points V2 and V3. So how do we do it? So with respect to V2, we can write it as V2 minus V1 by 2 ohms. So it's like one question is that why negative is not taken. I have just taken negative common factor. Since it will be equated to 0, it will cancel out. So you can write it directly as V2 minus V1 by 2 plus V2 by 1 ohm, because with respect to node 2 we are writing it. Now with respect to, since there is no other current with respect to node 2, we will go to node 3. So with respect to node 3 we have V3 minus 10. So there is a voltage source here, so we'll be writing it's going from plus to minus, or at the end there is minus sign. So V3 minus 10 by 5 ohm is the resistance value that is there. Now again for this, it is nothing but plus V3 by 2, that is equal to 0. All of these are supposed to be written as minus 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 and equated to 0. However, minus can be taken common and it will get cancelled out. That's why I've skipped one step and I've directly shown that. Otherwise, you can directly write it this way as well. That's not an issue. So once this is done, we can further simplify these equations and you'll be getting it in this form. This is equation 3. So solving these three equations, you will be getting V1 as 19.04, V2 as 11.6, and V3 as minus 8.4 volt. So this is what is our required answer, because this is what is being asked with respect to question. They've asked us to find the node voltages V1, V2, and V3. So be very careful in understanding the concept of supernode and supermesh. I hope it's very clear. Only thing is, while solving, at times we might live certain portions with respect to supernode and supermesh, so be very careful with respect to it. So we need to follow all these steps together. So if in case you go wrong at some places, remember with respect to number of nodes, if there are 3 nodes, you need to have 3 equations to solve them. Otherwise you will not be able to solve with respect to the given data. So that's it for today's video. If you have any questions, feel free to reach out with me. You can write down the questions in the comment section below. If you like this video, please do like it and subscribe to our channel for regular updates. Thanks for watching it.